Let's start the second part of this lecture here with the germ theory of disease. And that was really a brand new concept, that these tiny microbes that you couldn't even see, that they could cause disease. People didn't believe that. It took a long time to for this idea to even take hold, that yes, these bacteria, they can actually kill you, or they can cause definitely major problems. Ignaz Semmelweis, for example, he had a really hard time. He got fired over the idea that that doctors should wash their hands between patients that they were treating, because they might carry germs, in this case bacteria, a lot of times from patient to patient. They didn't want to hear that. And so when he suggested that they should wash their hands, he got fired over it, because he made a suggestion that the doctors actually were carrying diseases from patient to patient, and so the doctors didn't want to hear that. Anyway, some other people made some important contributions too. Joseph Lister, Robert Koch, major contributions. These are people you should know. Joseph Lister and Robert Koch made some very important contributions to how a bacteria can cause disease. Edward Jenner then came up with the idea of vaccination. Vacca comes from the word for cow, and he was actually pretty brave. He used his own son to demonstrate the first vaccination, a successful. He used the cowpox virus, which is very similar to smallpox, and he inoculated his own child with the cowpox virus, which doesn't cause disease in humans, and then demonstrated that his own son was now resistant to that he wouldn't get smallpox. And it was based on the idea that the milkmaids that were exposed to cowpox, none of them ever got smallpox, which was a big problem back in the day. And that observation caused them to come up with the vaccination. And then, of course, people were always looking for that magic bullet, the one magic medicine that would cure you from all of these bacterial diseases. And so the search for antibiotics, that's what we call it now, this drug, this miracle drug that could cure you and get rid of these bacterial diseases, it started early on. It was a trial and error kind of approach, trying different chemicals on your shelf. The first synthetic drug that sort of had some promise, sort of something off of somebody's chemistry shelf, was quinine, actually. And then also sulfonamides came out of that shotgun approach. Let's try everything we have on the shelf and see if it works, that kind of approach. But then the real breakthrough came with Alexander Fleming's discovery of penicillin, and it was accidental. He grew some bacteria and apparently got some mold contamination on his petri plate right there. And so he discovered that around this mold, so here's the mold growth, and around that mold growth he has a zone of clearing. There's no bacteria growing. So he concluded from that observation that, oh, there must be some substance in that mold that prevents my bacteria from growing there. And sure enough, years later, then he was able to isolate that substance, and it turns out it was penicillin, and he discovered the first antibiotic. So here are a couple terms that you should know. Bacteriology is the study of the bacteria, mycology, the study of fungi, and parasitology, the study of protozoa and parasitic worms. And here's such a parasitic worm. A lot of people think that this logo that you often see in conjunction with the medical profession, this thing here, this rod of Asclepius, that is a symbol for the medical profession. It comes from somebody taking a rod and pulling somebody's parasitic worm from their body. So it's kind of a interesting thought. But anyway, so here the modern developments in microbiology, sort of the second golden age of microbiology. Our understanding of the immune system and immunology in general has contributed much to the field of microbiology. And then recombinant DNA technology has made many things possible. We're using microbes these days to produce a bunch of medicines and pharmaceuticals, substances in general. So if you know about microbial genetics, and you can reprogram these microbes to produce the product that you want, so it's quite useful and very efficient. recombinant DNA technology. There's some important contributions, of course, the discovery of DNA, and then ultimately genetics. James Watson, Francis Crick gets the credit for that. And here is sort of a list of milestones in the golden age of microbiology. Let me just kind of point out some of the very important people. Of course, you need to know about Louis Pasteur, Joseph Lister, Robert Koch, very important contributions that came from them, and you should know them by name. Also, Ehrlich, Winogradsky. We might be doing this Winogradsky column, and that comes back to this guy. He was doing a lot of work with sulfur cycle. And then, yeah, so I think you can take a look at some of these, but definitely know Pasteur, Lister, Koch. So this is very important contributions. Here are some selected Nobel Prizes in physiology or medicine. And here you see them again. Robert Koch, the discovery of the tuberculosis bacterium. Then you have Fleming and his discovery of penicillin. And yeah, the other ones you may not have heard too much about. But anyway, microbes and human welfare. The recycling is a very important aspect of what microbes can do. Microbial ecology, that's the study of the relationship between microbes and their environment. And you can use bacteria to actually clean up toxic waste and use their ability to metabolize certain toxins and make them not toxic anymore. You can use that. You can also produce sulfur, nitrogen, and make different compounds out of it. Here's an example where you can use bioremediation. You're using microbes to clean up pollutants or toxic waste. Very useful. So here, bioremediation, bacteria degrade organic matter in the sewage, and they detoxify pollutants such as oil and mercury. So here's some examples, some images, how bacteria can help us clean up and detoxify waste. You can sometimes use microorganisms in insect pest control, and so there are some interesting aspects of that. We'll be talking about Bacillus thuringiensis. This one, the infections are fatal to many insects, and so therefore you can use that as sort of an insect control, this bacterium. And here is another example given here of a toxic crystal that is being metabolized by a bacillus. And so now let's take a look at the modern biotechnology and recombinant DNA technology. In recombinant DNA technology, we're manipulating DNA and then enabling microorganisms to produce what we want them to produce. And there's quite a few aspects to that. Our understanding of genetic material and how it works has grown a lot, and so there's a lot of different aspects to that, and we'll have a whole chapter on DNA technology later. So here, these are some of the things that you can do with genetically modified bacteria, even aspects of gene therapy where you can deliver genetic material to replace defective genes, for example. Now let's talk a little bit about the normal microbiota. Sort of bacteria, they tend to have this bad reputation because we think of them as germs, disease-causing, microorganisms. But actually, the vast majority of them is very beneficial, and our understanding of that has grown as well. And so the normal microbiota is actually working with your immune system to protect you from many disease-causing bacteria. And so this normal microbiota is quite important for your health and for your well-being. We will be talking about that much more. It used to be called normal flora, but nobody's using that term anymore. Everybody's using it microbiota, and there are all these probiotics that are being sold now, which are supposed to enhance your normal microbiota. And the normal microbiota is quite amazing, actually, in how it works with your immune system to help you stay healthy. So here are some examples of bacteria found as part of your normal microbiota. It's pretty generic here, so some pretty looking bacteria. the normal microbiota. It prevents growth of pathogens. That means it occupies growth niches and sort of makes that spot not available for something dangerous to grow. It also produces vitamins like vitamin B, vitamin K, very important, and really is important for your resistance, your ability to ward off disease. And so we found that people that have not a normal microbiota, they have a lot of times irritable bowel syndrome, or they come down with C. diff infections. And so it's actually the normal microbiota is keeping you healthy, and it's doing a really good job at that. We'll talk more about that. Biofilms is something not so good because these are sort of clusters or films of layers of bacteria that are hard to get rid of. And so if you have a biofilm with dangerous bacteria, it can cause big problems because the outer layers of this biofilm, they're shielding sort of the inner layers of the biofilm from harsh chemicals such as disinfectants. And then you're trying to disinfect something, but the biofilm was so strong that only the outer layers got killed, but the inner layers of this biofilm, these bacteria, are still alive and well and could cause big problems, especially when you have it on, let's say you have resistant antibiotics on some surgical instrument and you couldn't get rid of it, or some endoscope or whatever. That can cause quite a few problems. So here are biofilm on a catheter. You're getting this into a patient, and they're going to end up having problems. And let's finish off here with emerging infectious diseases. Of course, there's a lot to say nowadays about our latest emerging infectious pandemic. But here, let me give you some example of emerging infectious diseases, EIDs. And you probably heard about the bird flu, the avian influenza. That was an H1N1 strain. That was a flu. It was a flu virus, and that one made the rounds some years ago. Then we have methicillin-resistant Staphylococcus aureus, commonly known as MRSA. That one is sort of the big fear of all hospitals because it is resistant to even methicillin, which is sort of your last resort antibiotic. And nowadays we even have vancomycin-resistant Staph aureus. And these bacteria are quite dangerous because you really have nothing on the shelf anymore to treat them. Moving on to West Nile virus, and we had a few cases already this year, but of course everything is sort of taking a step back with the COVID-19 right now. But West Nile encephalitis can be quite dangerous. That's a virus that is transmitted by mosquitoes, and we have a few cases every year. Is one of those nasty mosquitoes sucking some blood. And then BSE, that one hasn't been in the news much, so that would be bovine spongiform encephalopathy. That's a prion disease, but lately we haven't heard much about that one. So that's we will talk about prion diseases in another lecture as well. And E. coli 0157H7, every now and then we have an outbreak. Chipotle took a hit on that one a couple of years ago when they had some cases of E. coli 0157H7. That is a type of E. coli that can produce bloody diarrhea and can be quite dangerous, even killing people. So here we have the this would be how this particular E. coli creates, how it invades your intestinal system, basically intestines, and how it can cause these perforations or this bloody diarrhea that causes damage to your intestinal walls. And Ebola, that one was also a big scare a few years ago. Right now, nobody's talking about Ebola. Very dangerous virus. There was outbreak 2014 in Guinea, and so that one was luckily contained and never turned into a pandemic. But here's Ebola, hemorrhagic fever, and so the virus. And then SARS, this one sort of the cousin to what we are dealing with right now. It's a coronavirus. And so SARS stands for Severe Acute Respiratory Syndrome. The latest edition of the coronavirus that's going around causing problems right now is SARS-CoV-2. So that would be SARS for Severe Acute Respiratory Syndrome, CO for coronavirus, V for virus, and then 2, the second one, the second edition of SARS. And this one is particular. Our current one is particularly bad because of the easy person-to-person transmission. Then AIDS. Right now, nobody's talking about AIDS that much anymore because we got some medicines to keep the virus in check. You won't be able to clear somebody from a virus, from this virus once they're infected. But in the United States, at least, there are medicines available that keep the virus in check for most people. And Zika virus was in the news a couple of years ago. I'm sure it's still a problem, but right now everything is sort of taking a step back and is in the shadow of COVID-19. But Zika virus is certainly also an emerging infectious disease causing microcephaly, abnormally small heads, as you can see here in these babies born to mothers that had Zika virus. And then, right now, this is our big deal thing, coronavirus, COVID-19, the novel coronavirus, the latest edition of the SARS virus. So it's very similar in its genome to the SARS virus. Slight variation, much more transmissible from person to person, much more dangerous, therefore. The latest news you can always check out on the Worldometer. Now there you can see it better. So the Worldometer has the latest numbers, and it is pretty sad how many people have died from this coronavirus. But anyway, I hope you enjoyed this first lecture, and this was an overview of Chapter 1, an overview of microbiology. Of course, much more to come, but for today, just stay safe, stay cool, and I'll talk to you soon.